Now we're going to look at the types of muscle actions. And we're going to get the governator or terminator, Mr. Arnold here. He's going to give us a hand. Muscle actions are used to either cause movement, control movement, or prevent joint movement, or to initiate or accelerate movement of a body segment. So when we want elbow flexion, all the muscles in there that cause elbow flexion will activate. They'll initiate or accelerate that particular movement. Now we can also do to slow down and decelerate movement in any body segment as well too. So when we go this way, we got elbow flexion. If we've got too much weight on there trying to come down, the muscle will fire and elongate, but it will try to, it's trying to contract to decelerate that motion. It's also to prevent moving a body segment or external forces. It's going to stabilize a particular, the muscles are going to stabilize that joint so other muscle action can take place. Good example of that is trying to do an elbow flexion movement, but what's going to stabilize the shoulder? Because you don't want this action, you just want to isolate that joint. So all the muscles around there, around the shoulder joint, are going to fire to stabilize that joint so it doesn't move. And also too, we don't want excessive pronation or supination in there too, so those muscles will fire. So we only have to do that, because if you look at some of the muscles that cause elbow flexion, they also help with pronation as well too, but we only wanted to do that particular action. So you can see how this is all working together. And muscle actions are either what they call isometric, same length or measure, that's isometric, same tension or same measure, or isotonic, which means same tension. But that's, you know, we're going to explain that a little bit more because that's kind of a contradiction in terms, but we're going to get to that to tell you exactly what that is. Now, let's look at an isometric action first. So if we look here, we've got a weight in our hand, and the weight has a certain amount of mass, and gravity is working on that to pull it down there. But we want, so you can see it's going down. But what about if we're holding it in that position? The muscle wants to fire and pull the forearm instead of going clockwise, and wants to go counterclockwise from this particular reference point. So that muscle is going to fire. But to hold it there, it's going to produce a certain amount of tension to offset that from going this way, and just to hold it there. Same with the tricep. If you look at that same way, but it's on a pulley, the weight's going down, but since it wraps around the pulley, it's going to cause our arm to go up there. So the tricep is going to contract, it's going to try to contract and stabilize to hold that position there. So it has active tension just to hold it there. The active tension is developed with the muscle, but the joint angles are going to remain the same. So in an isometric action, the muscle is trying to fire. It's not, the lever's not moving, the external load's not moving, the lever system at the joint is not moving, and the joint angle remains the same. It's what they also call a static action or static contraction, and it's trying to attempt to shorten. Now there's a significant amount of tension may be developed in the muscle to maintain this joint angle in a relatively static or stable position. That's an isometric action. May be used to prevent a body segment from being moved by external forces. So think about it, and if somebody's coming at you, we can put our arms out here, we're going to try to, they're trying to push us this way, but we're going to try to push back and hold them there. That's a static action, just the holding action. Think about it as a holding action. It prevents motion. Now, isotonic actions. Remember this word here, action. Involves muscles developing active tension to either cause or control joint movement. We have dynamic contractions or dynamic actions. And there's varying degrees of tension in the muscle resulting in joint angle changes. So if we look at doing elbow flexion, when the muscle pulls on that lower arm, the forearm, what happens? The tension is going to change because as this weight moves away from the joint, It's going to increase that moment arm there, so the muscle has to develop more tension as the weight moves away from the joint or axis of rotation. Once it gets past 90, it moves toward the joint again, so the tension is not going to be as great. Isotonic actions are either concentric or eccentric based on whether the muscle is shortening or lengthening. Now, the movement may occur at any given joint without any muscle contraction whatsoever. So how does that happen? This is referred to as passive. It's solely due to the external forces such as those applied to another person, object, or resistance, or the force of gravity in the presence of muscle relaxation. So if I'm standing here and the muscle is contracting, gravity's still trying to force me down, but the muscles are working to hold me up. But if I just relax, what am I going to do? I'm going to collapse. The muscles are going to relax and they're not going to be able to hold all my bones in the positions they're supposed to be, and I would just fall to the floor. Now this is a great chart and it's in your book. So if we have muscles under active tension, we're either going to have isometrics, the prevent motion or holding motion, or we're going to have isotonic, which means the muscle is either going to shorten, it's going to cause motion in a fashion. On the eccentric, it's going to try to contain or control that motion in the opposite direction. It's a very good chart. It's in the book. Now let's look at classification of muscle actions. Now let's look at the original terminology. We're in the fitness industry or the strength training industry, we're used to concentric, eccentric, and isometric. But the original terms come from Russian sports science, from a gentleman named Dr. Yuri Verkhoshansky, who was one of the world's premier specialists on speed, strength, speed, and explosive types of movements. The original term for shortening measure, what we call concentric, is called myometric, muscle shortening or shortened measure. The next term is called plyometric or lengthening measure. If you look at jumping exercises in this country, it's called plyometrics. It's what they call a stretch shortening cycle. The muscle is rapidly stretched and then it reverses direction and contracts in the opposite direction. Now, the original term is PLIO. Fred Wilton in 1970 was a track and field coach, and he was communicating with Dr. Verkhoshansky, but misinterpreted the actual spelling of this word. So he spelled it PLYO instead of PLIO. But all it is when we're doing a rapid stretch of the muscles, like when we do a jump. We come down, we lengthen certain muscles in the body, and then we reverse direction. We go through a lengthening, then a change in directions, which is called the amateurization phase, to go from lengthening to shortening, and then we explode up. The muscle goes from lengthening, eccentric, to concentric. That's what plyometric is. Then we also have isometric. It's the same measure, but this is the only term that we kept according to the original terminology. Like I said, the American modern terminology would mean concentric, which is myometric, shortening, eccentric, plyometric, lengthening measure, and we still kept isometric, and this term, the same measure, is still the same. We still use that term these days. So contraction and contraction involve muscles developing active tension as it shortens. Remember, if we look at a whole muscle fiber, the basic functional unit of a muscle fiber is a sarcomere. You got the Z line to Z lines, we got the actin and myosin filament, and the cross bridging in there. When the cross bridges from the myosin hit the actin fibers, and what happens? They ratchet. They're like little levers that grab and pull, grab and pull. But you've got some on one side, some on the other, and they pull the Z lines together. They're all in series, so each one of those sarcomeres will contract together. They'll shorten together, so the whole muscle fiber shortens. That's concentric. It causes motion, and it's the only true contraction. Remember that. Concentric is the only true contraction. Once again, we've got a weight in our hand, like a dumbbell, and if the weight wants to go down that way, so the muscle has to produce enough tension, enough force to counteract that movement going down to go upward. So the muscle is going to shorten to cause movement. It's going to pull on the forearm, it's going to shorten, it's going to pull in the opposite direction. The weight wants to go clockwise, and we're trying to counteract that with a counterclockwise movement. Same with the tricep. The weight's going down. The weight when it goes down wants to pull our hand this way. Our tricep will contract or shorten, and when it shortens, it pushes. We're actually doing a pushing action, but the muscle is shortening and pulling on the bone to cause that motion. Now, eccentric actions, it's not a contraction, it's an action, it's a lengthening action. Remember, contraction means shortening, eccentric means lengthening. So they're two different terminologies here, and we want to use eccentric action, not eccentric contraction. I realize the book says contraction, it's an old term, but we're going to use these types of terminology, muscle actions. Involves the muscle lengthening under active tension. It's a controlling motion. It helps to decelerate any types of motion. Even in the bench press, when we're bringing the weight down to our chest, that's an eccentric action. The muscles are lengthening, developing tension, and we reverse direction, that's concentric. The muscles are shortening. The front delt, the pec muscles, and the triceps are all working synergistically to move the weight away from the body. And this is an outstanding chart in your book, but it does have concentric and eccentric contractions, along with isometric contraction. In isometric, remember, the muscle's trying to contract, but it's holding. So, but this is, it's got a great chart that I'd like you to look through and ask some different questions. It's like a flow chart from a computer program. It has a specific command, and it says yes or no, and it goes in different directions. So I'd like you to take a good look at this and look at it to see how this works with every muscle in the body. Because once you know every muscle, origin, insertion, what joint it crosses, how it works, how it's arranged, the muscle fibers, what it does, and how they work together in any type of movement. Because if you're trying to teach somebody a movement, you have to know what muscles are involved in that, what are static and what are dynamic, to help facilitate that entire movement. Even at the joint, how much is the range of motions and how muscles hand off during that, throughout the entire range of motion of any movement. But this is an excellent chart. Now, isokinetics, they use a type of dynamic exercise where the speed is controlled in this particular device. So the speed is controlled, the muscular contraction in here, whether you're doing extension, knee extension, knee flexion, hip extension, hip flexion, hip extension, the speed is controlled because you're going against some kind of resistance on the machine. And the speed is controlled. What they're trying to look at is how much force you develop at a controlled speed. It's not another type of contraction as some have described. So it's not really a contraction, it's just trying to see how much force you can produce in a particular type of muscle action. If you look at Biodex or Cybex or Lido, they make these specific types of machines. They use them a lot in physical therapy and athletic training for rehabilitation. Now let's look at the role of muscles. We're gonna look at one of the best lifters in China, and we're gonna look at Arnold. They're gonna help us increase our knowledge of what are the role of muscles in the body to help make movement happen. Now, agonist muscle, it causes joint motion through a specific plane of motion, as we talked about, when contracting concentrically. Once again, concentric means the muscle is shortening. So whether we're having flexion and extension, and if we look at that, flexion and extension only happen in the sagittal plane. We have abduction, adduction through the frontal plane, and we have rotation, which happens in the transverse plane. But still, we need to look at what muscles are causing that. These are known as the primary or prime movers, or muscles most involved in causing a particular muscle action. or particular movement through a specific plane of motion or across all planes of motion. Now, these are the primary movers are muscles most involved. They also, with that, they have a primary mover. They also have assistant movers as well. The agonist muscle that contributes significantly less to the joint action or the joint motion. So you have primary movers, you have secondary movers, or synergistic or helping muscles that help facilitate that movement. Now, the consensus among most authorities regarding which muscles are primary, which muscles are secondary, which ones are weak assisters, or which ones are strong assisters. So it depends on who you talk to, what book you read to. But in every movement, you have a primary mover, you have a secondary mover, and assisting muscles as well. Now, the antagonistic muscles are on the opposite side. They're located on the opposite side of the joint from the agonist. They have the opposite concentric action. They're known as contralateral. Remember, contra on the other side, opposite side. They work in cooperation with agonist muscles by relaxing and allowing the movement. When contracting concentrically, they perform the opposite joint action of the agonist. So, we're doing a bicep curl. So, what's happened? The tricep is attached on the opposite side of where the bicep inserts our whatever elbow flexors we have. That's an elbow extensor. This is an elbow flexor. So what happens when we move that, the elbow extensor is going to relax, and the elbow flexors will do what? They'll contract. But what happens when we get to the end of it? We get to be to that range of motion where the muscle stops contracting because all the Z lines are all being pulled together about 50 to 60% of its actual resting length, so no more force production. A lot of times the antagonistic muscle will start to fire, develop tension to slow that movement down in any particular joint. So we talked about here, the tricep muscles are antagonistic to bicep muscles and elbow flexion. Now what about stabilizer? They surround a joint or particular body part. They contract to fixate or stabilize the area to enable limb or body segment to exert force or move. We talked about doing an elbow flexor or at the shoulder joint. The shoulder joint is stabilized, so we can cause this action here. So all those muscles are going to stabilize one joint so we can have movement at the distal end of this particular system, so we can cause that action. These are known as fixators as well. They are essential in establishing a relatively firm base for the more distal joint to work when carrying out specific movements. That's all it is. Bicep curl is one. But we also, if you look at, let's do this. If we're standing doing knee flexion here, what's being fixated and what's not. If we look at the hip joint, since we have muscles that cause hip extension, like the glutes and everything, they'll stabilize the hip joint. You also have hip flexors on the opposite side, but they'll all stabilize the hip joint. The trunk will stabilize. All the hip joint muscles will stabilize to keep that joint stabilized. So the leg is pointing straight down, so we can have just knee flexion. Now, synergist is assisting in the action of an agonist, also called a secondary mover as well. Not necessarily primary movers for the action, also known as guiding muscle, depending on what book you read. The system refined movements have ruled out any undesired motions as well. So if you look at synergist, fixators, and all that, we want this action to happen, but we don't want any kind of internal and external rotation. So we'll have fixators at one joint so we can cause this movement. We also have fixators we talked about before to do supination and pronation. We just want this action. We don't want the hand to do this at another particular joint, the radial ulna joint. We want the elbow joint just to work. These are helping synergist and true synergist. Now, helping synergists, they have an action in common but have action antagonistic to each other. They help another muscle move the joint in the desired manner and simultaneously prevent undesired actions. If we look at the anterior and posterior deltoid, if we look at that action, here is abduction. The medial deltoid wants to work in there. If we just fixate the shoulder joint and we just fixate the shoulder girdle, all right, we're going to do depression of the shoulder blade, shoulder girdle. We just want action at the deltoid. So all the muscles that are around the shoulder girdle will stabilize and hold the scapula in place. So we can just have action at the medial deltoid to cause abduction. But what about the anterior and posterior deltoid too? If we look at the anterior deltoid, it causes what? Flexion, and the posterior deltoid causes extension. Flexion, extension, abduction. But when we get to here, we don't want the anterior deltoid to do flexion in the transverse plane, and we don't want the posterior delt doing extension in the transverse plane as well too. So they'll fixate that particular bone so the medial deltoid will get all of the action to do abduction along with the anterior and posterior fibers as well of the anterior and posterior delt to help facilitate that action as well too. So we have to look at all those roles of those muscles and what they do and what action we're doing and what muscles are all involved and what roles they play. The anterior delt acts as an agonist in the glenohumeral flexion, while the posterior delt acts as an extensor. So once again, they're stable, they're helping fixate that so the medial delt can work nicely. They help each other and work in synergy with the middle deltoid accomplishing abduction, which we just talked about. Now, neutralizers, they counteract and neutralize the action of another muscle to prevent undesirable movements such as inappropriate muscle substitutions, referred to as neutralizing. They contract to resist specific action of other muscles. Okay, so when we're looking at when only supination action of the bicep brachii is desired, the tricep brachii will neutralize the flexion action of the bicep. So we don't want the bicep, we just want the bicep to do supination here. But we don't want it to do flexion. So if we look at that, the tricep is going to fixate that action there, so we can't do elbow flexion. It's gonna fire to hold it in that place so the bicep can do supination. Make sense? Bicep can do supination and it can also do elbow flexion. But we want it to be controlled, so it's going to hold it in that position so we can just do supination. These are the roles we need to look at of all the muscles involved in a particular joint action.